So welcome back to my OOP in Java tutorial, and in this video I'll be making a brief introduction about object-oriented programming and what object-oriented programming is really about. So let's go straight dive into it. So what is object-oriented programming? Object-oriented programming, this is a programming style that organizes software design around classes and objects rather than functions and logic. So if you're from a programming language like C programming, here you had procedural programming whereby you would organize your functions in a procedural way. But here in object-oriented programming, it gives you the capability to organize your software in classes and objects. So we shall look at what classes are and what objects are. But in other words, what you need to know is that under OOP, code is organized into objects rather than a sequence of instructions. And from this diagram, this is procedural programming, let's say in C programming, whereby you would write your code in a sequence by sequence. But in object-oriented programming, we organize our code in objects, in classes, and then we can encapsulate, add security, hide a few details using abstraction, reuse certain classes using inheritance, and then a class can take more shapes using polymorphism, as we shall see. So you might be wondering, why should we use OOP? So one of the advantages of using OOP is that you can be able to reuse your code and maintain. Code is really easy to reuse and maintain because it is organized in classes. So you can use a certain class, you can create a method and then override it or overload it, as we shall see. It's also easy to expand a program, or what we call scalability. So look at it like this. You've really started designing your software. Maybe you're designing a software for a school, and in the beginning, you were just designing a software that registers students and teachers. But in the long run, you realize you need to add a fees registration, you need to print reports of students, you need to know how many students drop out. So the demands of the software keep on increasing. So that's where object-oriented programming comes in, that you can easily expand your program with the increasing needs. Then code is also easy to organize and to read. When you've organized your code in classes, you've created your methods well, and you have overridden them very well. Code is really organized and readable, that even if you are a software program of a certain company, someone who comes after you can reread your code and becomes very easy to understand. Then OOP also offers security capabilities through encapsulation, as we shall see. So this takes us to the 4 pillars of object-oriented programming. So this is what we shall be tackling in this course, and this is what makes OOP actually very special as compared to the procedural programming that you saw in other programming like C. These are the 4 pillars. We have encapsulation. Here, the encapsulation, we are looking at hiding data to protect its integrity. I shall use inheritance, whereby a child class inherits properties from a parent class, and this enables us to really reuse our code and extend our code, as we shall see throughout the course. Then the third pillar is polymorphism. Polymorphism is taking different behaviors. So you have the same function, or you have what we call methods. You have the same method, but then it can have different behaviors, as we shall see during the course. And then finally, final pillar is abstraction. And here with abstraction, you're hiding complex implementation details. So maybe just to break it down into real examples, look at encapsulation in such a way. You have a car, but in a car, you have a dashboard. So when you're on your dashboard on the car, you can really see what is happening in the engine, whether there is fuel or what, but you cannot really see the engine from the dashboard. So the engine is hidden somewhere inside, you cannot see it, but you can only interact with it via an interface, for which case is the dashboard. So that's a good example of encapsulation, and it's how we are going to use it in Java. Then inheritance. So inheritance, think of a family, look at your dad. So you realize there are some features which you inherit from your father. So the same way you inherit some features, maybe your father was brown, maybe your father was tall, and you're also tall. That's also in inheritance is used in Java. That a child class can inherit properties like methods from the parent class. So and also we look at polymorphism in this way, that a cat and a dog can both make sound. They make it differently. A dog barks and a cat makes it sound. So the whole idea is, the method is, they both make sound but makes it differently. So I hope that breakdown really makes it easy for you to understand. So how does Java implement OOP? So the key takeaway here, what you need to know is that everything in Java is inside a class. So whatever code you write is organized in a class. That's why in our first program, in the previous video, I showed you the class and we wrote our code inside a class. And another thing you need to know is that objects interact via methods. So Java supports all the OOP principles that we saw behind. So maybe this is a quick code snippet of how a class is formed. So this is a class of a car. It has instance variables, which is a string brand and int speed. So the instance variables, and it also has a method for acceleration. So this is how we write a Java method, void accelerate, and just like that, I've showed you how we implement a few OOP principles. So as we wind up this lecture or this video, this is the key takeaways that you really need to go with in this video. One is that OOP is a structured approach of programming. So that makes it different from procedural programming languages like C. It helps in better code management and reusability. And Java is fully object-oriented. So now I have a simple quiz for you. If you really have been following, please, you can pause this video, take it behind and answer. So which OOP principle allows an object to take multiple forms? 1. Encapsulation. B. Inheritance. C. Polymorphism. D. Abstraction. Please answer this quiz and you can comment with your answers. I see you in the next video. Thank you so much.